Good morning. We're going to create Conway's Game of Life in C today. Or if not today, this is going to be a series of videos in which we are going to develop a graphical simulation in C using SDL of Conway's Game of Life. And what is Conway's Game of Life? I assume most of you already know it, but let me just Google it for you. Game of Life. C. And this is the Google search result. And as you can see, Google even embedded an Easter egg in the search results right here. So this is quite a popular computer, science thing. It's a simulation that, depending on initial conditions, simulates how certain, cells develop, how they move, how they reproduce, how they die, these things. So it's quite interesting. Let's have a look at this one. I can just fill a couple of initial cells, and depending on which cells, depending on how the cells are structured, they are going to move. And I want to replicate this in C. We're going to do that today. So these cells, they move according to certain rules. Let me just look that up. And yeah, these are the rules. So there are basically 4 rules. A live cell dies if it has fewer than 2 live neighbors. Okay, just like in real life, if you have nobody around you, you're going to die. You depend on other people. A live cell with 2 or 3 live neighbors lives on to the next generation. So that is basically reproduction. A live cell with more than 3 live neighbors dies. That is starving because of resource exhaustion. And a dead cell will be brought back to life if it has exactly 3 live neighbors. So that sounds also like reproduction. The last one is reproduction. The second one is just persisting. Okay, so basically we need a UI, which is a grid of, it must be a grid of cells, and we have to display that in a C environment. And to do that, we're going to use SDL, which is a graphics library, or, to be more precise, it's a multimedia library. And we're going to do that just now. Yeah. Okay, so let me just have a look at where to create that project. I will create it here. Let me just make this a bit bigger for you. Make directory, and we're going to create the Game of Life. Should we call it Conway's Game of Life? Yeah, maybe Conway's Game of Life. And then we're going to switch into that directory, initialize tmux, then split the terminal window in 2 because I would like to compile in one pane and write the code in another pane. And I'm going to open Vim and create a new file, gameoflife.c, gol.c. The first thing that we can do for sure is include standard io.h, which we're always going to use, and we're going to include, I think it's sdl2 sdl.h. I have to look that up already. And we're going to do this by checking out the SDL2 documentation right here. So this is the official documentation of SDL2, and I find it quite helpful actually. So there's an installation guide, and that tells you which compilation flags to use. So we can use that already to test something. We need to create a main method, int main, like this. Let me just start off with a hello world. hello Conway's game of life. And in this bottom right pane, we're going to compile stuff. So we're going to compile this using the CC compiler. It's built into Linux. I don't really care about compilers, so I just use what's already there. CC, and we're going to create an output file, game of life. And we're going to compile gameoflife.c. And then we're going to use these compilation flags from the SDL documentation, which we found here. And well, here the documentation uses the GCC compiler. I just use the CC compiler. Why do I actually use CC? I think when I read this old book on the C programming standard, that they used CC there for the code examples. So whenever I use C, I just use CC. I think GCC is usually used for C++, which I have no idea of. And yeah, I'll just stick to what I know. And as you can see, this already compiled successfully. If I execute game of life, then I get the printout right here. So that is working fine, but I would like, well, to code the game of life. And to code the game of life, we somehow need to create a graphical user interface. And the way to do that is we have to initialize SDL. So let me just look for initialize, maybe video, SDL init. We're using, by the way, SDL2, not SDL3. There's no reason we're using SDL2. It's just the library I started with. And the one I installed on my machine. There are not too many differences. It's just SDL. And the method that we're going to use is SDL init. And it takes as input a set of flags depending on which subsystems we want to initialize. So let me just type SDL init. And then we have to provide flags. And we basically just want to create a graphical simulation. So the only flag that we need, here there's a listing of all the flags, is the video flag. Because we just want to do graphics. If we would like to do audio as well, then we would also use this flag and then concatenate them together using an OR operation. So I think we should just do init video, and this statement should work. I'll just compile it just to be sure, and it did work. And the next thing, now that SDL is initialized, well, it does still not do anything. As you can see, I still get this printout, but no window opens, and that is because we still have to come on, just adding the new line here. That is because we still have to initialize, or no, not initialize, we have to open a window. And to do that, let's just have a look at the documentation. And by the way, what is the point of all of this? Why are we doing this? I mean, we could just go to ChatGPT and type create Conway's game of life in C. And that's it. We would get a printout and it would probably work. But if you just do something like that, if you just prompt an AI to do it, you learn absolutely nothing, and life gets sad incredibly quickly that way. You need to somehow do something in life, you know? Every shortcut makes you less happy in general. It's like, oh, I would like to run a marathon. Oh, we have a new marathon AI, and you can prompt it to teleport you to the goal in just a couple of seconds. No, but that's not the point. We want to run the marathon, and we want to see whether we can do it, and we want to grow. So that's why we're doing this. So that's for all the AI guys. I still use AI, but not today. Okay, so we would like to open a window right now, and to do that we need the API. I would just open the complete API index and then search for window. That's quite nice because usually the API names, they match what you want. So if you want to create a window, you search for a window using Control F, and then you usually find what you need. So that's the function that we're going to use. We're going to call create window. Let's just do that. Now we're going to have a look at the arguments that are required. So SDL create window. And then there's a title that we're going to provide. Let me just make this an extra argument here. Variable here. Okay, character pointer. And we're going to call it title. Or window title, Conway's Game of Life. Good. And then we can reference that here. The next argument is the x coordinate, the y coordinate, the width and height of the window, and then all of that is followed by flags. And here in the function parameters, there's already a suggestion to, if you want to, initialize the window at the center of the screen, you can just use these two flags, window position centered. Yeah, it's the same flag for X and Y, and that's going to work already. So we're going to do a SDL window position. Am I doing something wrong here? SDL window pos. Okay. SDL window centered. Then again, SDL window pos centered. And width and height. These are, let's just start with, no, let's just do it properly this time. Last time when we coded Pong, I just hard coded all of this. And then in the end, I ended up creating or extracting all the hard codings into variables because they were needed all over the place. So let me just do a width equals 900 and a height of 600. Width and height. I'm actually on annual leave right now because due to some hardship supporting family members in hospital, and I'm surprised that I've still got the Vim keystrokes down. So I'm quite happy with that. Somehow Vim sticks in your fingers and it's not forgotten. It's like riding a bicycle. Okay. And width, height, and flags. What are the window flags? Let's have a look at what they are. You can do full screen and all of these things, but we don't need them probably, so we're going to pass a 0. And this will not yet create a window. The reason is that, it will just print the message, but not create a window. The reason is that after creating the window, we exit immediately because after that, our main method is done. So the software quits and we need to provide an SDL delay. How do I know that? Last time when we created a Pong clone, and we had the same issue, and this is basically the same initial setup. Yeah, so now once we execute the software, we have a window and it sticks out for 5 seconds. Later on we will make this window persist once we create the simulation loop, and we'll create all the simulation steps over and over and over again. But for now, I'm quite happy with already having a window. So this is already quite nice, and it has the title Conway's Game of Life. So these are the routine SDL steps you need to do to create a window. But now we would like to make this the game of life. And to do that, I am looking for, well, somehow we have to model our problem. So let me just open up Paint. I wish I could do this black. It's better on the eye, in my opinion. Where's the fill icon? Sometimes I really miss the old the old Paint, the Windows XP version. Okay, so this is our Conway's Game of Life window, and Conway's Game of Life is based on cells. So we have a ton of we have a pane that is the area we draw to, and then we split this into quadratic cells like this. These are the columns. Can I copy this over? Yeah. No. Yeah, you already get my point, I guess. And then we have the rows like that. And of course the rows are full screen width or full window width. Yeah, this is a bad example now. Oh, like that. Okay. Let me just finish this up so nobody is going to complain in the comments, oh, this was painful to watch, as always. Okay, and think of a fully created grid. So this is practically like a chessboard. And the contents of that grid will be either filled, a filled color. Let me just make it green, or no color. So this is going to be the game of life. And practically speaking, this is just a matrix of zeros and ones. 0 if there's no filled value, and a 1 if there is a filled value in the cell. Yeah, and based on these filled values, we're going to create the next simulation step. But I would like to start off in this episode, and hopefully we get it done, by creating such a grid. And then we have to model our problem through a matrix, basically. So let me just start off and create. Well, what do we need now? We need a pane to draw to. So we have so far created a window, that is the window right here, and we want to draw to that black area. And in SDL, this black area is called a window pane, if I remember correctly. So let me look for pane. No, it's not. Is it pane? No, sorry, it's surface. And we would like to get the window surface. Where is it? Get the window, yeah, and there's a perfectly matching method signature, get window surface. And I will just copy this and paste it here above the delay, because I actually want to see what we're doing here. And we're going to create this SDL surface variable, call it surface. And that is equal to get window surface, and we provide the window here. And window is going to be I think it's the output from the get window method. Let me just confirm this. If we have from the create window method, yeah. And it returns the SDL window here. So let me do that as well. SDL window pointer window. And please, if my C skills are a bit odd or something is off, then please let me know in the comments. I'm a complete beginner myself. So we have now a window, we have a surface retrieved from that window, and based on the surface, we should now be able to draw a rectangle to that surface. Let me check. Let me find out where that is. Draw rect. There's render draw rect. So that is drawing a rectangle using a renderer. A renderer is basically a tool that helps you draw graphics to the surface, but for a game of life, that is so simple. We just need black boxes and we need white boxes, so I don't think that we really need a renderer. You would need a renderer if you would like to, for example, print fonts to the surface, or if you would like to print, well, some graphics files to the surface. I think you can draw images, definitely these bitmap files. Yeah, we don't need that. We just need simple rectangles. We're just going to do the game of life. So how do we draw a rectangle? I know we already did that in the Pong video last time, but yeah, I recorded that a month ago, so I already forgot. So please excuse me if you know exactly what to do at this point, and I don't, even though you might know it from my last video. There's the fill rect. Yeah, that's the one we need. Fill rect. So this is, what does this do? It performs a fast fill of a rectangle with a specific color. Let me just do this. Yep, okay. Okay, so here we have the fill rect call. We're going to draw to a surface. So let me just pass the surface here. Then we have to provide a rectangle. Like that. We will initialize that in a second. And then we will provide a color, which we will also initialize right now. So the rectangle is going to be an SDL rect, and that is a structure we can initialize using, where is it? Here, a rectangle with the origin at the upper left. Okay, so this right here is the structure. We have to provide X, Y, and width and height. So X and Y, let me just do dummy variables. X, Y, width and height. And we're going to cast that. I don't know if it's casting, I still don't know. Yeah, I should know by now, but yeah, I'll just think of this as casting, and we're going to pass that to the rectangle structure. We do create the structure, and here we pass this by reference. We're going to pass the pointer to that. So here we have to pass the address of the rectangle, and then we will also have to create a uint32, which is an unsigned integer of size 32 bits. That is the color, and the color white is basically, well, I'm using white since we're printing on black background, so that is very simple to see. And the color white is hexadecimal FF. Do we need more? FF. Let me just try that. and I'll call that color white. Color white here as well. And this should be a uint32 that reflects white, because two hexadecimal digits together are 1 byte. So this is 1 byte, 2 bytes, 3 bytes, and 4 bytes. 4 bytes are 32 bits, because 1 byte is 8 bits. And let's just compile that. It worked, great. And let's have a look at the game of life execution, and we don't see the rectangle. I think this happened last time as well. The reason we don't see the rectangle is because we have to tell STL that there is now a rectangle on the surface, and you have to re-render the surface. You have to refresh the surface. So let me just look up how to do that. We fill the rectangle. Is there a refresh? No. Update maybe. Update window surface. There it is. Copy the window surface to the screen. Yeah, right. We're creating the surface, and it's just data. It's data in memory, and we have to copy that window surface data to the screen, so that we can actually display what we're drawing. And we're passing the window, and the window is associated with the surface, so that's why it works. Okay. Let me pass that. Window. Okay. And let's compile and execute the game of life. And there it is. This is our first rectangle. And this should be enough for now. Yeah, so now we showcase that we can create a window. We can draw to that window in pure C, which is already quite nice, I think. And the next step would be to, let me think. We should model the problem according to how we did that in Paint. This is what we talked about here. And I would say we should define how many rectangles we have. Why do I always get these error sounds? Maybe I will turn them off now. You should still hear me, I guess, but you won't hear my desktop audio. Okay. And okay. So we need to define how many cells do we have? Cells, or how many columns do we have? We have, let's just do 100 columns. Having 10 columns or 100 columns does not make the problem easier or harder. It's just a variable, and I think I'm thinking of what would look good on the screen, and maybe that's 100 columns. And how many rows do we have? We would, I think a good count would be, well, let's fit it to the, let's make it even more clever. Let's make it width divided by 10. So that is the pixel size. Here we say basically that each cell is 10 pixels wide. And we can then also say that the rows are the height divided by 10. And then we can also extract that into a cell. What is the side of a square called? Cell width. Let's just call it cell width. And that is 10. Cell width and cell width. Okay, yeah, we didn't do anything, so that's why the game is still unchanged. And now I would like to draw that matrix onto the screen. I would like to draw that table onto the screen. And to do that, we have to call a method that is draw grid. And that's the method that we're going to create ourselves. That is, what does it take as input? Cell width, columns, and rows maybe. I think this should define everything. And then we need to define that method up here. Int draw grid, and it's going to accept cell width, int columns, int rows. And let's just draw some lines here. Now it's definitely going to be a nested for loop, or it's going to be, we can do two separate for loops. The first for loop, let's do like this, is counting from 0 to the count of rows, and we're going to draw the rows now. 0 to rows, and it's going to count up. And now we would like to draw a line. And maybe this should be a single method, but I will just do it like, I will just do it in here first, just to make a proof of concept. And we're going to do, what are we going to do? We're going to, we have to create a rectangle. A rectangle is practically what we need because we want to draw lines. We want to draw a grid. And each line of a rectangle is basically a rectangle with a width of just 1. I mean, a line is a thin rectangle, so that's the line of thinking right now. And we're going to call it line. And that line is going to be an STL rectangle. And the structure, so where does this rectangle start? What's the x coordinate? That is the top left coordinate of the top left x coordinate. And that should be I multiplied by cell width. So let me just have a moment and think about this. So for row 0, I will be 0. So the x coordinate will be 0 as well. For row 1, it will be, for row 1, I will be 1, and cell width will be some constant. So we're going to draw below that. No, we're changing the x coordinate here, so we will move to the right. So we're actually drawing columns right there. We don't want to draw columns, we want to draw rows. We have to move the y coordinate down, and the x coordinate has to be fixed to 0. You know, because each line in the grid starts at x0. It starts at the leftmost part of the grid. Okay, I hope you can follow my point. I guess you can. So there's the 0, and then we're going to change the y variable each time. And then we have to specify the height, no, the width first. The width is going to be the screen width. Let's call it surface width right here. And the height is going to be 1. Yeah. And here we need to pass the surface width an integer. Okay. And then we need to provide that when we draw the grid right here, surface width is width. Is that the surface width? Actually, it's the Windows width. I don't know what the difference is between those two. Maybe the surface width is a bit smaller, or maybe the surface width is what we define. I don't know. Let's just keep it like that and see if it misbehaves later on. Unused variable line. Where exactly? Ah, yeah, of course. We initialize the rectangle, which we call line, and then we have to draw that rectangle. SDL draw. Was it draw rect? Let me just have a look at how we did it here. So here we created the rectangle, and here we did fill rectangle. Aha, okay. Okay, so let me just copy and paste that here. We need the surface as well. And that's a lot of parameters into that method. Maybe we can clean that up later on. SDL surface pointer, and we will use a pointer here. And then we're going to draw the line like that. And the color is going to be white. Maybe we should define that as a global constant somehow. Can we define that color white somehow outside of the main method? I guess we can. Yeah. Looks good. Now what is wrong here? Ah, of course I used the wrong brace. Okay, and because this is a constant, I will rename it to color white in capital letters and apply that same change here. And where's the other color white? It's down here. So let's just pass the surface here as the first parameter, and that works, so that is good. And I think right now we don't have any compilation errors. We just need to refresh the window probably after drawing the grid, and we can do that here. We draw the grid and then we do a update window surface. And let's also put the SDL delay behind that. Okay, I will recompile. Compilation works, great. And execute that. Okay, we have now the first rectangle and we have the grid lines. So that is nice. I just find the grid too tight. So, and that was the point of the cell width. Now we just have to adapt the cell width and we get a bigger grid. Let me just change this to 30. And now it looks like this. This is good for a start. Wow. The window looks very odd when I refresh. Yeah, when I refresh it. No, I mean when I resize it. Okay, but now we have the rows, and I would like to do the same thing but for the columns. So we just copy the for loop. We will create lines, and here, as we just found out earlier, we need to change the x coordinate to to I multiplied by cell width, and the y coordinate will it always be 0? Yeah, because each line is drawn from top to bottom, so the starting y coordinate is going to be 0. So we're going to put a 0 here. And what is the width of that line? It's going to be 1. And the height of the line is going to be from top to bottom. So this is going to be the surface height multiplied, no, not multiplied by anything. It's just going to be the surface height. And we don't have the surface height at this point, so we probably need to pass it in here. But we should make it a global constant, just like the surface width. So let me just define it here. Surface width is 900. I will remove that from the method. I think we can define these as global constants because they don't change, or they won't change during the execution of the program, of the simulation. And then searching for surface width, we can replace it here. Oh, come on, surface width. Where's the next surface width? There is no more. Yeah, now we should also replace the width here with surface width. Okay, and we can do the same thing for the surface height. That is going to be 600. It's just an arbitrary value. You can change it to whatever you want. We're going to search for surface height. And that is here. Replace that with surface height in capital letters to refer to the global constant. And then we also have to replace the simple height constant or variable using the surface height. Oh my god, heights. Oh, and I almost messed up here. Surface heights. Okay, and here of course we don't need to pass this as a method parameter. Surface is going to be a method parameter. Cell width is not going to be a method parameter because this is globally defined. Let's just do that. Cell width is going to be 30. And let's search for cell. We're going to delete that and delete that as well, right like this. Let's look for the next occurrence of cell width. It's here. Change that to capital letters, cell width. Next occurrence, change. Next occurrence, delete. This occurrence, cell width. And that is it. Let's see if that compiles. I'm not sure. Oh, it does compile. I'm not sure if how this actually looks in the compressed video uploaded to YouTube, but actually this is a good grid. because I'm seeing this in my in my recording software, and somehow the grid looks odd, but it looks perfectly fine. Maybe I will just space out the grid lines a bit to just ensure that it does not look weird on video. Because sometimes when you do 1 pixel graphical elements, just like a thin line, then video compression behaves weirdly. So let's just define also a line width. And that line width is going to be 2 pixels. I'm not sure how much that does, but well, we will see. And then here, this is going to be line width as well. So let's have a look. Okay, this should look better now on video. And of course, we don't need that 1 rectangle which we rendered to the screen. We can remove that. So now what have we achieved? We have drawn a grid. That is good. We have drawn the lines of the grid. And now what's missing is to actually simulate something here. Maybe it looks better if we don't use white lines and use gray lines. Because the individual cells are going to be white, and having white lines all over the place is maybe too much contrast. And now I'm acting like a front-end engineer here and wasting time on colors. Well, let's just do another color here, a gray. Color gray. I never know whether to use a write gray using E or A. So please correct me if I'm wrong. And this should be a gray. No? Ah, yeah, of course, because I haven't changed the code to actually use color gray. Color gray. Color gray. Ooh, that looks elegant. Ooh, I really like that. That looks quite nice. It looks like looks really professional actually. But I think on video this might be a bit too dark. So let me make the gray a bit lighter by increasing the bit values. Maybe 2F, 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 2F is going to be a lighter gray. Okay, yeah, I think this is a good gray. And now I would like to color that grid. And no, I don't want to color the grid, but I would like to define an initial set of cells to be used. Maybe let's keep it very simple, and let's just start with 1 cell. Okay, and that 1 cell that we're going to draw is well, I don't know which one, but let's start with a top-down approach and just call a method that does not yet exist. Let's just say draw cell to the surface. And I would like to specify the coordinate of the cell. That is going to be cell X and cell Y. Okay. And cell X is going to be 5. And cell Y is going to be whatever. No, let's make the Y a bit bigger. 10, and cell Y is going to be 6. Okay. I'm really enjoying this right now. I think we're... Damn me. Okay. I think we will get something done today. My goal before this episode closes is to just draw this cell and see how this turns out. Draw cell takes in an SDR surface, pointer surface, and then it takes a cell X and a cell Y coordinate. Let's just simplify this to X and Y. I mean, everything should be as straightforward as possible. So we're drawing a cell to the surface. Actually, to make this more abstract, we could say draw a cell to grid and somehow model the grid, and then the grid should be drawn and the grid will be drawn to the surface. But I don't think we need that much abstraction all the time. Sometimes the simple stuff is good enough. And let's figure out how to draw that cell to the surface directly. Now, the cell width is already defined. It's going to be a square. So let me just quickly check if it compiles. Yes, still compiles. So the cell width is defined. The cell is going to be a square. That means we have to somehow find the location of the X and Y grid entry. Oh, here the X and Y could be confused with the X and Y pixel coordinates. So I will change this back to cell X and cell Y just to be unambiguous. Okay. How do we find the location of the cell? We basically want to draw a rectangle. We're going to fill rectangle on the surface. We're going to provide the pixel X coordinate, not the cell X. We have to convert that to which pixel on the screen is that. And we are going to provide the pixel Y and then the cell, and then the width and height of the cell. And because it is a square, we can just pass the cell width twice. And then I think we have to provide the color at the end. That should be the syntax. And now we have to define we have to find out which pixel coordinate is that cell going to be. So the pixel X is going to be here. Technically speaking, I'm just clarifying what I'm thinking. We're drawing a grid, and we have separated out the cells using lines, but the lines themselves, they take up space as well. So should we consider them in the calculation? Strictly speaking, we would have to. But I think if we draw the rectangle over the grid, after filling the individual cells, there will not be a big difference. Let's just do the simple approach, and let's just assume that the pixel X coordinate is the cell X. So for example, cell X is going to be 10. That means we have to go to the right by the cell width. Now at this point we would have to consider the line widths as well, but let's just ignore that. I think it will turn out well as well. So cell X multiplied by cell width. Is that already it? I just imagined this might be a bit more complicated, but let's do the same for Y as well. Then we will call fill rectangle. Why does this not work? Where did I use the first? I just deleted it. Okay. We have to pull up the documentation again. So fill rectangle. We pass the surface, the destination surface. Of course, yeah. We have to define the rectangle structure. And the rectangle structure is SDL rectangle, cell rectangle, and it's going to be an SDL rectangle, and these are with those parameters. Wow. No. Wait, how do I copy this properly in Vim? I highlight it, I delete it. Oh no, let me just yank it. I will go to the end here. Okay, I managed to do it. Okay, now I can delete all of these parameters here and provide the cell rectangle as an address. And here we need to put the semicolon to the end of the line. And that should be it. Yes, and that is it. And as you can see here, we already see the line width problem that we talked about. The rectangle is overlapping the line a bit. But we could work around that. Either by considering the line width here, pixel Y, we would have to add the line width on top of pixel Y, pixel X, line width. I'm not sure if that makes the things too complex. Or alternatively, without all these calculations, we could just draw the grid on top of the cells, which might be the simpler solution. Maybe let's just draw the grid on top of the cells. Yeah, here we're drawing the grid and then the cell. Let's just inverse that and draw the cell below the grid. Of course, that doesn't work since I did not compile. And let's execute this as well. And this looks now as if the cell is within the boundaries of the grid. And that is great. And let's make this look like Game of Life a bit more by drawing a couple of cells here. And this is just to sum up this episode. Of course, in the next episode, we will make this we will generate these cells dynamically. So I will generate another cell at 10 and then at Y7, then another cell at 11, Y9, and then maybe another cell at, let's just say 15, 9, and another cell at 8, 4. Let's have a look at how that looks like. And that is our Game of Life starting point. Let me just make this a bit more Game of Life like, just by adding one more square here. Yeah, I'm happy with that. Okay, and remember, all of the complexity, all of the simulation that we're going to do. We're going to do that in the next episode. This episode was just implementing the window initialization, drawing to the window, and drawing the grid, drawing the first couple of cells. And in the next episodes, we will continue with actually performing the simulation and have everything move, determining how fast the simulation will go, all these things. And it's going to be really interesting because now that we have the fundamental structure, we basically created a game engine for Conway's Game of Life, some API to code against, something to draw the grid and draw the cells. But next time we're going to do the actual game logic, the simulation logic. And I hope you will stick out and follow along. And yeah, if you're interested in more of that, then leave a like and subscribe. And let's see you next time in the next episode. Bye.